Hello everyone, this is Jim. This is going to be the lecture 4 video. The topics that we're going to be covering in this lecture are going to be the hole wizard. We're going to be going over how to create through holes and blind holes, counter bores, counter sunk holes. We'll also go over a little bit of the drawing symbols that encompass those, as well as how to create tangent planes and add colors and also add material properties. So let's just go ahead and let's dive right in. Create a new document. Sketch. Just gonna grab a plane. Let's just create a square for now. This should serve our purpose. Give this 6. 6 here as well. And we're gonna extrude it. Make it 6. So we got this nice box shape. This should be good for us to practice with the hole wizard. So we're going to go up right here and we're going to click on hole wizard. Now if you look here, it's got a couple different types of hole options that we have. We've got just create a regular hole, a countersink hole, counter bore, uh, a straight tap, taper tap, a couple other different really good options that we can use. A slot, countersink slot, counter bore slot. So the features that you typically see the most are the holes, countersinks, counter bores, and tapped holes. So let's just go through them one at a time. Let's start by looking at just the holes. So first we're gonna create a position. So we're gonna click on position right here. We're gonna click on a surface. And we're just gonna create a point, and that point is where the center of the hole is gonna be. So we'll just select the midpoint, just like that. We're going to go through what our options are. So we got on this drop down, we got the different kinds of standards that are typically used in industry. You'll most commonly see ANSI inch used, particularly in America. You'll see some other standards used in different parts of the world, like ISO in Europe and whatnot. But ANSI inch is what we're going to be mostly using. And we also there's options to uh, decide which kind of drill bit sizes we want to look at. So we typically you're good about just using the all drill sizes, but if you want to just narrow it down, you got multiple different kinds of options right here. So let's just stick with all drill sizes right now. So if you look at the drill size, let's go and let's turn on the show decimal values. This will have a huge database of all the different drill bits that we can use to create this hole. So we're just going to click on quarter for now. And now we have the option to input our end condition. So if you look right here, that's the depth of the hole that we're going to be creating. Now if you notice real closely, you can't really see. So that depth is before you see this angled bottom at the bottom. That's a result of the drill bit. The drill bit typically uses angled out. So that's the depth of which the constant cross area that you're going to be calling out. So if I put 2 in, that's going to be 2 inches, and then down here you'll see the pointed end of the drill bit. So we can just go ahead and we can create that like so. I'm going to create a section view so we can see it nice and clearly. And there we go. We've got a drilled hole right there. Let's go back in. Let's edit it. So I also have the option to just make it a through hole, make it go all the way through. I also have some other options to add near side and far side countersinks as well to this. So if I click on near side, that'll allow me to input the angle of the countersink and also the diameter of the countersink. I can also do the same thing on the far side as well. I click on the far side, all the same options come right up. So it's a little bit of how the whole works. Let's take a look and go through the through counterbore right now. So once again, you have the different standards you can choose from. We're going to stick with ANSI inch, and if you click on this drop down, it'll allow us to determine what kind of screw that we're going to be using. A binding head screw, hex bolts, all different kinds of options. Let's stick with just binding head screw for now. And now we have the option to tell us what size bolt we're going to be using. So we're going to stick with a quarter bolt. Let's take a look at what we got here. So show custom size. We're not going to change anything. We're just going to take a look at what we got here. So I can tell it what kind of fit I want. So if I got a quarter-inch bolt, quarter bolt, I'm going to need a bit more tolerance on my through hole diameter. So if I go to normal fit, it gives me this 2.66 inches. It's pretty standard. It's a pretty consistent industry standard of 2.66 that's used for a quarter bolt. Also have close fitting for circumstances which a higher degree of tolerance is required. Also got loose where it's even wider. Let's stick with normal for now. Let's take a look at what other options we have. So it's got the standard diameter of the counter bore. I can change that as I see fit, and also has the standard for the depth of the counter bore. That's based upon the bolt that we're calling out. So we'll go ahead and we'll uncheck custom sizing for now. We're gonna leave everything as is. So end condition, I also have the option I can make a blind, or I can go through all as well. Now let's look at the other things we have. So head clearance, I have the option to increase the clearance for the head of my bolt. So I can just add distance, and that just increases the clearance of the head. So think of it as I'm creating this counter bore. I've already got my bolt in there. That's the clearance I have between the top of the bolt and this top surface right here. So that's what this is. So I can put it at 0. I still have the counter bore, but that's going to have the head of my bolt in plane with my top surface right here. So it's typically a good practice to add a little bit more clearance for the head bolt, but that ultimately depends on what your assembly needs are required. So let's look at the other thing, near side countersink. We can also have the option of adding countersink to our counter bore. And the same thing as underhead countersink. As well as a far side countersink. So let's go ahead and let's create our counter bore. Hit OK. We've got our counter bore through hole. Well, maybe I didn't make it a through hole. I think I made it 2 inches, left it blind. No, I did. It's a through hole. Alright, let's go back in and let's take a look at countersink hole now. Let's go ahead and just click on countersink. Once again, we have our drop downs. We have our ANSI inch standards, and we're going to stick with that. Now we can choose the type of screw. Typically, there are 2 different main industry standards that I call different angles. So the 82 is very common among common machine parts, but 100 degree is really common in the aerospace industry. So that's you can pretty much get this based upon very easily based upon whoever's manufacturing your hardware. You can get this angle called out easily, and you just pick the one that's most appropriate for the hardware that you're using. So let's stick with 100 for now. Once again, I can call out the size of the screw, and I can also call out the fit that I feel that is necessary for my design. stick with normal for now. Control the end condition, blind through all, so on and so forth. Add head clearance. That just increases my depth. Or I also have this drop down where I can do that by increasing the size of the countersink, or just add a counter bore. And once again, I can also add a far side countersink as well, which will just add a countersink to the far end. So I'm going to go ahead and create that. And I've got a countersink hole made for a very, very long 1/4 inch bolt. And we're also going to look at the tap. So the tap, well, gotta make sure I get this unchecked. So let's go ahead and let's look at the 1/4 bolt again. So if you see here, it's 1/4 20, so that means it's a tap for a 1/4 inch bolt that says 20 threads per inches. So we're going to look at this right now. We're going to look at what we got here. So if you look at the custom sizing, let's see what we got. That's the diameter of the what the machinist will ultimately drill out from the hole, and then he'll tap it to add the threads. We have the option to control what we call out on our call out as well. So let's just go ahead and make that. I don't think it's got what I want it on it. Let's go back in and let's look at it. That's what I want to have checked. So if you look at here, this is what I got here. So I've got my through hole requirement called out on the inner diameter. This outer diameter is what's going to be the tap size, and that's going to tell the machinist that, okay, I want to have, for a 1/4 inch bolt, you need to drill out this size of material, and then you're going to tap it to create this diameter. That's what ultimately was going to allow the 1/4 inch bolt to thread down into the hole. So that's just a little bit of basics of the hole wizard. You guys can go ahead and you can experiment and try things out as you see fit. So let's go ahead and let's go over how to create tangent planes. So last lecture we went over how to create planes that are normal to features. Now I want to go ahead and go over how to create planes that are tangent to features. So let's go to sketch. Let's grab the top plane. Let's draw a circle. Ladder dimension. Let's make it 10. Extruded boss base. Let's make this 10 also. Okay. So I got a rounded surface and I want to create a plane on this rounded surface, so I can go ahead and create holes on different points on this shape here. So I'm going to go to references and I'll select on plane. So my first reference, I'm going to select this surface. And I'll be able to create a plane on it, but I can't control where along the surface that it is. I need to give it another reference. The best way to do that would be first create a sketch and draw a line out to this edge right here, so I can add a coincident reference for this plane as well. So let's just go ahead and let's do that before we make this plane. So on this top surface right here, I'm going to sketch, select here, go normal to, create a construction line, so center line, draw this out here, and we're going to create another one. It's going to go up to here, and let's add it at angle distance 40. Okay, go ahead and we'll exit the sketch. Go back into features, preferences, plane. We'll select the surface. And now I want to put the plane coincident to this point right here. So I'm going to select that. Boom, it locks it in. This plane is going to be coincident with that point. And I've got a fully defined plane. I can go check OK. And there we have it. I can do the same thing with that other point as well. So plane. Oops. This is plane. Grab this surface. Grab this next point. And boom, I got another plane right there. Just like that. So you go about creating tangent planes. So let's go about how we go ahead about adding colors. So just for cleanliness sake, let's get rid of these planes right here. We don't need them. We demonstrated how to create them. Get rid of that sketch as well. Say I want to add some color to this. How can I go about doing that? So if I go over here, I can click on Appearances, Scenes, and Decals. So I drop down on the colors, and I got all these different options that I can pick from. Different colors of plastics, high gloss, medium gloss, so on and so forth. Metals, so different kinds of steels, polished steel, cast carbon steel, all the different options. Glasses. And if I click on solids, it just gives us, boring white, red, orange, yellow, blue, pink. Let's just go ahead and let's pick a color. Let's drag it out to this here. So I got the option to pick what I'm going to be creating with that color. So I can click on, so if I got multiple features, I can click on the face. That'll make this face right here that color. So I can create this feature in my feature tree, the Boss Extrude 2, the entire body, or if I've got multiple bodies within a part, I can just click on the part and it'll make everything this color. So we'll click on part, and everything is now that color that I wanted. Simple enough. Now, let's say I want to go ahead and add some material properties to this. So the way I can go about doing that is I come up to here where it says material. Material is not specified. So I can right click on it, click on edit materials. And Solidworks has a huge library of materials already built in, all different kinds of steels, irons, aluminum alloys, copper alloys, so on and so forth, all kinds of different things. So I'm going to go ahead and I'm going to make it aluminum 6061. So I can just come down here and make it 6061 T6. It's a very common industry aluminum. And it's already got a bunch of properties built into it. It's got the elastic modulus, Poisson's ratio, the density. The density is what we're going to be mostly worried about, because we're not going to be doing a whole lot of analysis, but we'll do some weight analysis. So I want to go and apply this. So just click OK, hit apply, then hit close. If you look up here, it shows that I've added the material to this part right here. And if I want to see how much this part weighs, I can just now go up to evaluate and click on mass properties. And right here it'll show me how much my part weighs, as well as it'll give me the center of mass. Pretty good stuff. Okay, so say I wanted to create a custom material. I can do that too. Say I've got a manufacturer who gives me some interesting properties of a different kind of alloy that's not programmed into it, or maybe a different kind of plastic. So what you'd want to do is you'd want to find something that's similar to that material. So let's just make it easy on ourselves, and let's say it's aluminum alloy that's like 6061, but a little bit different. So I come to 6061, I can click on it and click copy. I'm going to come down here to my custom materials and click on new category. This new category, I can give it a name. Let's say aluminum custom. Then I can just right click on it, click paste. I can go in here and I can edit all these properties now. I can make this 0.12 and apply it. I can give it a different name. Let's see, special aluminum. Apply. If you look up here, it is now my custom material. So I'm going to close it, pick mass properties. You can see it weighs a little bit more now to reflect the change in density. Alright, so I think we got enough new skills to continue forward with some examples. Let's take a look at what we got going on today. So, come on. Look at our first part. It doesn't look too bad. So I'm going to go up to File, New, Part, and I'm going to go and create a sketch. Let's start with the top plane. Because looking at this part, I think it would be easiest to start with this entity here and then make this separate. So let's start with a sketch. Let's create, create a circle here. That is going to be, let's go ahead and let's just sketch in an arc here. Another arc down here. And let's just make this, put a circle here. Okay, and then I'm going to create another arc here, and then another arc here. I don't want that horizontal. I know it's going to cause me problems. I'm going to delete it now. Alright, so let's start going through this here. So I've got a dimension of 0.71 for this. I want to go ahead and make this and this tangent. Do the same thing here. Okay. This is going to be radius 2. This is also radius 2. And I've got this and this tangent. And this and this tangent. Okay. I've got this and this. I can't really do that. So this is going. Let's go ahead and let's trim up some entities. Let's trim that. Trim that. Smart dimension. I want this to be 0.71. This is also to be 0.71. Okay. Then this is 2 inches. Okay. And this point, vertical. Okay. And let's go ahead and let's create a line here and a line here. I want to make this and this tangent, this and this, oops, this tangent, and we're going to give it radius 0.6 for both. Okay. We'll make this and this, oops, this tangent, this tangent. Okay, and we've got a distance here of 0.63. Alright, so need to go and add another reference. I'm gonna make it a center line here, and we're gonna go symmetric here. Okay, and I'm going to go ahead and I'm going to close these contours off. Going to make this vertical, and I've got a distance from here to here of 4.325. There we go. And I'm going to go ahead, I'm going to extrude this now. I'll make it, it's 0.394. Hit OK. Alright, so I'll leave the holes for last. So now I'm going to go about creating this part right here. So let's go ahead and let's create a new sketch. We'll select, which plane do I want to use? I want to use, is it front plane that I want? I want front plane. That's what I want. Go normal to, and so I've got a hole there, and I've got an outer hole, another circle right here, and I've got, let's create an arc that runs from here down to here, and then I've got a straight line that runs from here. It's going to connect here. So let's make this horizontal. We'll go ahead and we'll make that and this tangent. We'll make this and this tangent as well. We'll give it 4.5 as our radius. Okay. Now I've got, what else do I got? What's this coincident with? I don't want coincident with midpoint. No, I don't want that. It's going to cause me problems. So I've got, so if you look at the drawing, it's dimensioning this off the center of the through hole here. So let's go ahead and we'll add that in. So we got from here to here. That's 4.325. Let's see what's broken. Let's just delete this for now. So I got a couple problems here. Let's get rid of that for now. Okay, let's get rid of this. Yes, I want to get rid of that. We'll move this up out of the way. I think it's probably just went a little too quickly. Let's go ahead and let's make this. Oops. That is 0.785. Okay. And then this is 1.75. Alright. And now I can put this in easily. I think it just picked up a few things I didn't want. Let's go ahead and let's go and make this and this tangent. This and this tangent as well. Make this 4.5. Oh. Let's see. Oh, that's right. Yeah, that's right. Okay. And then I will go ahead and draw a line here, here, to here. And we'll go ahead and we'll make horizontal. Should lock everything in nicely. Trim entities, get rid of the extra junk. I think that's everything I need. So go to features, extrude boss base, mid plane, and 0.63. Sure, merge is selected. There we go. That's our shape. Now let's go ahead and let's add the holes now. So they're all, what are they? They're all 0.472. Sketch. Oh, let's look at the hole wizard. Let's see what we got. So hole positions. Put one there. 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 So let's see, we got a hole here, and this is 2. This is also 2. And let's see, I assume they're going to be concentric. This and this concentric. Let's see here. I think I've got too many. Let's get rid of this here. Delete that. Yeah, there we go. That's the problem. And this is concentric. What? Why is it giving me problems? Let's just go back. So let's X out of that. So let's try that again. Hole wizard positions. Let's just start with one there. We want a point there. We want a point there. So now I can go up here, I can select that. Smart dimensions. Concentric, there we go, that's what I want. See? Add that, grab that, and make it concentric. Yep, that's what I want to see. That looks good. And then I'm just going to grab a point and pull another one right there. So type, we want a regular hole, and so 0.472. What could that be? That could be. Let's just go ahead and show decimal values. It'll make life easier. 0.472. Well, it's not really a standard drill bit size, so we can go ahead and let's check that one for now. That should be fine. And there we have it. There's our part. So you could have just made this as just an extruded cut as well, but just for the sake of this lesson, I'm going to try to use the hole wizard as much as possible. Let's go ahead and let's save that one and move on to the next one. So this is example 1. Okay, let's look at the next one. Alright, so it looks like we're going to have extrude here, be a tapered extrude here, then an extruded cut there. Doesn't look too bad. Let's go to new. Select sketch. I'm going to start with the top plane. And let's go ahead and let's create the base. Start with that. We've got to have another here, and then we'll have another one out here somewhere. And then it looks like we've got a outer diameter for this one of 3.25. A line that goes here to here, here to here, one that goes from here to here, alright, let's see, I need my tangent relation here. Oops. Tangent, that's what I want. Let's see, tangent, coincident, tangent, coincident, tangent. Alright, looks good. Alright, so I'll go trim entities, get rid of that, get rid of this, get rid of that, and I'll get rid of that. So I want to make this radius 0.75. And this one also 0.75. Okay. I'll go ahead and I'll add a center line in to make sure these are all so this at this point. Actually, maybe I don't want a center line. Maybe we just want to add in a horizontal relationship with this midpoint. Horizontal, yeah, that'll do us nicely. So grab horizontal. There we go. That looks good. Let's see. I'm still under constraint. Am I under constraint still? What do I need? Oh, duh. I need this dimension. Let's see. That. I'll grab that. There we go. 4.5. I'll need a center line here. So this point, this point, this symmetric. There we are. That looks right. So I'll go ahead and I'm going to create an extrude. This is a thickness of 0.5. There we go. Alright, well, let's go ahead and let's make this right here. So this will probably be good for a tapered extrude, 15 degrees tapered extrude. So sketch, create a circle, make this 3.25. Features, extrude. This is going to be 1.5, and we're going to want a tapered extrude of 15 degrees. There we have it. All right, now let's go ahead and let's create the cutout in the middle. So let's go to sketch. We're gonna grab these plane do I want? Front plane. All right, let's go ahead and let's add in our center line. We're definitely gonna want that. Okay. So I've got cross, down, 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 cross, and then down, up, up, close. Alright, so dimensions I've got, what do I got? What do I have? So I've got 1.5 across like that. I have, let's see, based upon the top view, I've got 1 inch here across, and I've got 1.75 for up here. Alright, then I've got 0.38 here is 0.38. Okay, and then I've got, let's see here, 1 inch from here to here. That's 1 inch. And I've got 0.75 for here. Alright, there we have it. I'm going to go up to features, revolve cut, 360 degrees, about this center line. There we go, that's what I want. Boom. I can go to section view, and there's my cutout. Simple enough. Go ahead and save it. Okay, let's look at the next one. Alright, so I got this shape here. I've got some countersink hole called out here. So I think it would be best if I sketched this side first and did a mid-plane extrude and then added in these other features after the fact. So let's go ahead and let's do that. Alright, so start with a sketch. Let's grab the right plane. I'm sketch on the side first. So I've got down, 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 in, up, across, across. I think that's right. Alright, so dimensions. I've got here to here, 4. I've got here to here, 3.5. Should I bring this in? Okay. I've got 0.5 from here to here. I've got an angle of 45 degrees here, so I'm going to add in a construction line. 45 degrees. There we go. That's nice. I've got 1 inch here. I've got 2 from here to here. Alright, I've got, what do I got here? I've got 1 inch here. I've got 1.75 from here to here. Okay. I've got, what else do I got? I got 3 from here to here. There we go. Everything goes black. It's good. Alright, so I'm going to go ahead and do a mid-plane extrude. And this looks to be 3 inches. There we go. Looks good. So I think I'm going to go ahead and create the little cutouts here and here. So I'm going to sketch, grab this surface here, normal to. Let's see, what do I got? I want a center line. Alright, I'm going to create a corner rectangle. I'll create one here, and then I want one here as well. We're going to make them symmetric about this line. I think they're both, yeah, they're both 1.25. So this one also symmetric. And then they are dimensioned 0.25, 1.25. Just check that. Yes, that is correct. And they're also filleted internally. I'll do that afterwards. Okay. So I'm going to go ahead and exit now. So I'll select Sketch, Features, extrude cut. Now I think I'm going to start by just extruding this contour first, and we're going to use an up to surface. So extrude up to the surface. Hit OK. And I'm going to extrude the next contour as a through all. There we go. Looks good. I've got some radiuses in there that I need to put in, so I'm going to select fillet. Grab that, and then that, and this is going to be 0.33, no, 0.033. There we go. Now I got some countersink holes on this surface I need to put in. So let's go up to Hole Wizard, Positions. We're going to sketch on the surface. Nope. That's what I want. Okay. So let's put in a center line. And we're going to create a point here, point here. They are both going to be symmetric about the center line, and 0.707 from here. Okay, and their distance apart is going to be 1.5. Okay, and I've got 0.5 through and 0.5 diameter countersink at a 100-degree angle. So I'm gonna do a hole. That's got the drill bit size that I want already programmed in. So I'll go 5.5. It's a near side countersink. It's 100 degrees, and I don't want 50. I want 0.25 here. That's what I want. 50. No. 0.5. 100. That's what I want. I want it to be through hole. Yep. Got the drawing is also calling. Looks like it's got a far side countersink as well, so I'll just put the same in. Same. Both sides. There we go. That's our drawing. Go ahead and we'll save it. And let's take a look at the next one now. So I got this shape here that I gotta make. Alright, doesn't look too bad. Looks like it should probably start with this on the origin and then go from there. So let's do that. File, new part, sketch. Going to grab the front plane. Alright, let's just take a look here. I've got a circle right in the middle. It's got radius 1. Is that 1.75 there? No, it's not. Diameter 1.125. Alright, and then I've got this outer arc here. So the radius on this is 1.75, so I'll put 3.5 in for now as the diameter. And I think I'm going to want some center lines now. I'm going to want one that runs down this way, and I'm going to want one that runs horizontal as well. Okay. I want a circle on this line and on this line as well. I want, let's see, what else do I want? Another circle here and another circle here. Okay. These holes are both 0.5. This is 0.5. And it's 0.5 as well. So I've got, let's see, I've got this drawn out to here. I've got another line here, and I got this arc here. Alright, so I'm going to make this and this tangent, this and this tangent as well, and then this and this tangent. Alright, so I got some dimensions to add. I got 5 from here to here. It's 5. I've got, let's see what else I got here. I got 5 here to here. Oops. I don't want to grab that. Yeah, that's what I want. I want 5. Okay. I want an angle of 0.75 here. And it looks like I want a radius dimension here. Display as a radius of 0.662 here. Okay. I don't want that. I want, is that coincident with the arc, or I can't tell. I don't think so. Let me get rid of that. I think it's going to cause me problems. Let me go and make that coincident again. Alright, well, let's just keep checking it out. I want, where'd my radius go? Oh, that makes sense. I made it 0.75 instead of 7.5. That's what I want. 7.5. That makes sense. So why it looks so weird. Okay, that makes sense now. Okay, so now I got 2.5 here. And I've got another, let's see, 0.75 here. I'll do it again. I did do it again. Okay, so now I've got show this as a radius. I've got 0.662 here. Okay, that should lock everything in quite nicely. So I've got another line that runs here out to here somewhere, and an arc that attaches it to this circle. Okay, this is also 7.5. Okay, this and this are tangent. This and this are tangent. And I've got dimension of 1 here. Alright. And I got the same over here as well. Make those two tangent. We'll do the same here. Tangent. Okay, dimensions. I've got angle, let's see, 7.5 here. And I've got a radius of 1 here. Okay. I think I've got this first good. Let's go and trim entities so get rid of the extra junk. Alright, that looks good. Now I can create the other part of the drawing. We'll go center line. I'm going to draw this out here, and I've got an angle 135 between here and here. Okay, that's good. I got a circle somewhere out in space here. It is, let's see, what do I have? Got a radius 1.75 here. Okay, I've got distance. I've got distance from this point here to this point of, let's see, I don't think I've got that distance. Let me hold off on that for now. Let me get rid of that. I've got a hole in the middle here, and it looks like it's keyed. So I've got a line that's going to go across like so. Excuse me. Trim entities. Get rid of that. Get rid of that. Get rid of that. And get rid of that. Okay. I've got a radius of 5.63 here. I mean 0.563. I want to make this and this perpendicular. Okay. Let's see, what do I got? I've got this line and here. That is 1.875. Okay, I've got another line across here. Gotta add trim. Okay, this line is also going to be perpendicular with this. And I've got a distance from this point to here of 3.625. Okay, that's good. And I've got, what else am I missing here? I've got that position isn't locked in. What am I missing here? What do I need? What more do I need? What don't I have? I probably put this dimension in here. I might lock it in. I've got 2 here. No, I don't want that. There we go. That locks everything in nicely. Alright, so now we can go to trim. We get rid of all the extra stuff. I think that's everything. Oh, get rid of that. Get rid of that. Get rid of that. Get rid of that. There we go. That looks about right. Let's see. Those points are coincident. Yep, they are. Alright, so now we're going to go ahead and extrude. We're going to go to, let's see, features, extrude boss base. We're going to extrude this contour mid-plane, 1.5. Okay. We'll do the same thing. This contour is mid-plane 0.75. There we go. And it looks like I've got some rounds I gotta put in. Let's see. So drawing calls out 4. So there, maybe there? Yeah, that's there. Okay, so let's fillets. I've got 1 there, 1 there. There. And there. This is 0.5. There we go. There's our part. And just for the heck of it, let's add some color to it. We're going to make it a metal, aluminum, polished aluminum. So we're going to make the entire part. It's aluminum. And we'll go ahead and make it aluminum too. So material, right click, edit material. I don't want steel, I want aluminum alloy. C1, apply, close. Alright, mouse properties. 3.7 pounds our part weighs. Alright, so that's our 4th part. Let's go ahead and let's save it. Now let's take a look at our next one. Our last one. Alright. This one doesn't look too bad. Looks like we got a base here, wall here, and a rib, and a couple countersinks here, and this right here as well. So I think I'm going to go ahead and create this here and do an extrude this way, then make this, and then make that, and then add the countersink holes in. So let's go ahead and give it a try. So Solidworks file, new part, sketch. We'll grab the front plane, and we're going to go. Let's see, what do I got here? I've got. Start with the center line. I don't think I'm going to want that. Go across, go symmetric. thickness, I've got. God, who did this? Who made this drawing? Okay, I've got. Let's see. Equals 0.63 minus 0.25. Is that right? Yeah, that's right. So that's that. And then I've got length of 1 plus 0.63 plus 0.63. Alright. And let's see here. I'll go ahead and I'll put that in, and then we're going to extrude it 3.88. So I'll go ahead and we'll just create another rectangle. Go symmetric. And that's 0.75 here. And 0.25 here. Okay. Little trim entities. Extruded boss base. And it is 3.88. Okay. Now I'm going to make the backside. So features, sketch. Okay, I've got up, cross, down, across. Okay, I'm going to want a center line. And I'm going to make these points symmetric. That's what I want. I've got, what do I got here? I've got 2.25 from here to here. I've got one here. That should lock everything in nicely. I've got a thickness of 0.5, so I'm going to go extruded boss base. Other way, 0.5. There we go. And I got this rib that I'm going to put in now, so sketch. Let's see, do I got a plane I can use? I think I can use the right plane. Yep, the right plane should be good. And that is from here, 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 here. And I've got, let's see, what do I have here? It's what's my length? What's my length on this? Huh. Doesn't really call it out clearly. Let me look at this a little bit closely here. Let's see, 0.5 there. I've got I'm not seeing it anywhere. That's weird. Alright, well, just for the sake, I'm just going to give it some kind of dimension. We'll make it, what do I got in here? We'll make it 2.7. Not going to waste our time. Extrude boss base. mid-plane, and I've got 0.5 is my thickness. God, that's really bothering me. I can't. Is there not a dimension on that? So 1.45. Yeah, that's looks like it got neglected. All right. So, but that's not really what's the most important about this drawing. Now I want to put the countersinks in. So I'm going to go to features, hole wizard. Since they're not standard countersink holes, so I'm going to use countersink positions. Normal to, and we're going to create a center line. Okay, I'm going to have a point here, 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 here. Okay, I'm going to have this are symmetric. Okay, and this vertical, and this are that symmetric. I think I grabbed something else that I shouldn't have grabbed. Get rid of that. This symmetric. There we go. That's what I want. Okay, so I've got 1.38 from here to here, and then I've got 1.38 from here to here. And then they are both 1.25 apart. Okay, hole type. So hole through all, I want, let's see, 0.25 on the through, 50 here, and then 45 here. No far side countersink through all, and I think that's what I want to see. Is it what I want to see? Doesn't look right. Based upon the drawing, looks like that's right. Let's go 90. Yeah, that looks more consistent with the drawing, with the drawings calling out. So yeah, I wanted to use 90. I think it looks better than the 45 that I saw in the picture, and looks like I got a couple chamfers also. Let's go and put those in. Those are both going to be 0.375. There we go. There's our last part. Alright, now let's about do it for this lecture. I'll see you soon.